Letter Y. A solution of sodium bromide is added to an acidified solution of potassium bromate. We are again considering the redox half reaction, so I'm getting an indication that this is a lot like our previous example. So, knowing that we are thinking redox, the first reactant was given to us as sodium bromide, NaBr. We know to eliminate that first family spectator ion and think about the ion bromide, forming molecular bromine, Br2, as our first half reaction. The other reactant was given as potassium bromate. Now, bromate is a polyatomic ion, BrO3. It's a +1 -1, so here's the salt, potassium bromate, but I'm going to eliminate the potassium, that first family spectator ion, and begin considering the second half reaction, bromate going to the molecular bromine. So we have the same product that we're targeting. What we'll end up doing to balance this first half reaction, we'll need to balance the Br negatives, and then simply add 2 electrons to the right-hand side to balance the charge. In the second half reaction, we will begin by writing, to balance the oxygens, we need to add 3 waters. That gives me a total of 6 hydrogen ions. 6 H's, 2, you know what I didn't do? I didn't balance this right here. Let me repair, I'm sorry. I gotta balance the bromines first. That gave me 6 waters to balance the oxygens, and that gave me 12 hydrogens. I'm glad I found that. So I have 12, 2, 1, 6. And now let's consider the charge. I have a +12 and a -2, so that's a net of a +10, and the right side is neutral. So we'll need to add 10 electrons to the left side of the equation. Sorry, this is not neat. 10 electrons plus 12 hydrogen ions plus 2 bromates is what the left side is reading. If we lose 2 electrons in the first, but we are gaining 10, we'll need to distribute a 5 to make Leo equal Gur. And we'll do that as we come back together and add the 2 half reactions. So distributing a 5 through the top, I would get 10 units of Br negative. On the left side of the arrow, plus 10 electrons, plus 12 hydrogen ions, plus 2 units of the bromate polyatomic ion. On the right-hand side, we have 5 bromine molecules, 10 electrons, a bromine molecule, and 6 waters. Let's see what we can simplify. Again, the electrons are canceled. And we need to combine a Br2 with 5 Br2s. I'll just go ahead and add those together to produce 6 Br2s. Anything else? It looks like if I have 10 Br negatives and 12 H positives and 2 BrO3 negatives, forming 6 Br2s and 6 waters on the right hand side. Now I'm noticing this can be reduced. Cut that all in half and we get 5 units of Br negative plus 6 units of H positive plus 1 unit of BrO3 negative, yielding 3 bromine molecules and 3 waters, balances our equation. And again, the half reaction, this time we're being asked for, is the reduction half reaction. Gain of electrons is reduction. So our Gur reaction would simply represent that half reaction balanced for mass and charge. 10 electrons plus 12 hydrogen ions plus 2 bromates yields a bromine, and 6 waters would be the answer to the question, the half reaction in which we balanced with the gain of electrons.